Good morning. Today is day 2 of the probability unit, and I'm going to hope that the video works a little bit better today than it did yesterday. So, cross your fingers here. What we are looking at for today is representing sets, right, and probability just itself, right? So the first part, when it says, what is a set? Well, a set is a collection of elements from well-defined criteria. So a collection of elements from well-defined criteria. And we'll explain that further as we go. So when it says, all right, well then what's an element? Because we're saying it's a collection of elements. That's just the individual term that's contained in a set. Or an individual item, right, contained in a set. So let's do this example to kind of show what we're talking about. It says set W is defined as the collection of all integers that are greater than 0, less than 10. So integers, those are just nice whole numbers, right? So when it says write out set W in roster form, we're going to write it using just our little curly brackets here. So the set, when it says it's elements in a well-defined criteria. So we're defining that they have to be integers. They have to be greater than 0, less than 10. So it's very specific. So that means we're talking about the numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then close it on up. Right? So what would be an element then? An element would be like each individual number. So like 1 is an element of the set, or 2 is an element of the set. There you go. When it says show W in a Venn diagram, all right, Venn diagrams, you guys, is when you have the big box and then you have the circles within it. You don't necessarily have to have the box itself, but the set is usually represented by a circle. And then we put like the label on the outside for W. And then all the numbers would just be inside. So you can list the numbers 1 through 9 within kind of the bubble there. That's what our Venn diagram would be. All right. I actually saw a really funny Venn diagram. Maybe somebody sent it to me. Maybe I'll post it on here so you guys can see it. Next part, define a set C that is a subset of W, and then list the elements in C. All right. We could pick anything, but you have to make the criteria very specific. So if I say set C, I could say, the odd numbers from 0 to 10. I could say even numbers. I could say numbers greater than 0 but less than 4. Those are all examples here. All right. So maybe I'll go with that last one. Integers that are greater than 0 but less than 4. There's a very specific set that when I list it out would be a subset, because it would just be the numbers 1, 2, and 3, a subset of set W. What is the intersection of W and C? Well, that's asking where they overlap. So the intersection looks like that, with the notation, like an upside down U in between. And the numbers that they overlap would literally be the subset itself. That's what they have in common. So it would be the numbers 1, 2, and 3. So when it says explain why the answer would be the same regardless of the subset you had picked. Well, where would this set overlap with this one? It has to be everything within here. So even if we had said all the even numbers between 0 and 10, or 0 and less than 10, sorry, greater than 0, less than 10, where this set would overlap with this one, since all these values are inside of that, it would always come back to be whatever this set is that you picked. There you go. The next one, the empty set. Literally draw your cute little curly bracket and put nothing inside. That is called the empty set. So I'm going to write it as there are no elements in the set. The other way you can say it is a 0 with a slash through it, or you could simply say no solution, which we actually have said a lot throughout the year. When we get an answer and we have to reject it, then there's just no solution, right? So empty set is another way to show that. You just want to make sure, don't put this like inside of there. The idea is you're literally showing an empty set, okay? All right. The next one back to some tree diagrams. I think the tree diagram on yesterday's notes actually did show up. I know some people said it might have been a smidge tough to read. So as always, you guys, reference the notes on the website. You can even print them out and then just watch the video as it goes through. Whatever you need to do to make, learning as easy as possible for you. So it says, draw a tree diagram that represents all outcomes in the sample space of rolling 2 4-sided dice. All right, so 4-sided dice, those would be little triangular pyramids, if you can think geometry style. That's how you'd have 4 sides there. So the idea, all right, is when you roll the first time, there's 4 things that could happen. You could land on a 1, a 2, a 3, or a 4. At least that's what I'm assuming that the sides would be. All right, so that's your first roll. All right, then you're going to roll again. You could have the same things happen again. All right, or I shouldn't say roll again. This would be the first die, and then the second part would be the second die. So you could land on 1, 2, 3, or 4. This could land on 1, 2, 3, or 4. Same game, and same thing here. So this would be the second die. All right. So it says, how many outcomes are there? The number of outcomes is always the same as the number of branches that it has. So you got 4, 8, 12, 16. So 16 combinations that can happen here. When it says, what's the probability that you do not get 2 of the same number? There's a couple ways you could do it. You could actually go through and say, like, okay, that includes a 1 and then a 2, a 1 and then a 3, a 1 and then a 4, 2 and then 1, and so on. Or you could look at this as, what's the probability that you do get the same number? Well, same number would be like a 1 and a 1, 2 and a 2, 3 and a 3, 4 and a 4. That would be 4 out of 16. So then the probability that they're not the same would just be the complement of that. So 1 minus 4/16 would leave us with 12/16, or you can reduce it down to 3/4. So there's a 3 out of 4 chance that you're not going to get the same number twice. What is the most likely sum of the dice? All right. Well, that you have to do a little bit more thinking about. So let's write the sums underneath. So if you get a 1 and a 1, that would be a sum of 2. 1 and 2 would be a 3. 1 and 3 would be a sum of 4. Let me keep going. This would be 3, 4, 5, and 6. This would be 4, 5, 6, and 7. This would be 5, 6, 7, and 8. So you can see that we get sums anywhere from 2 to 8, but they're saying which one is the most likely. So which number do you see the most? Well, if you look, you can get a 5, whether you rolled a 1 first, a 2 first, a 3 first, or a 4 first. That's the only situation that happens in all 4 cases. So the most likely sum would be a sum of 5. And then what's the probability of that? Well, it happened in 4 out of the 16 cases. So we could say that that probability is 1/4. There you go. There is the first page of the notes. Now, something I didn't mention yesterday, but the filled in notes on the website might look the tiniest bit different than the notes that I do with you on here. Don't let that throw you off. Sometimes we update things, and unfortunately, I am not at school to be able to update everything perfectly. I wish I could, but I can't. So if they are slightly different, you didn't do anything wrong. That's me. All right, let's move on to the next page. This page is kind of fun to look at. So the example that you're being given here, oops, let me slide back so you can see, says an online bookstore offers a large selection of books. Some of the books are fiction, some are not. Some of the books are available as ebooks, and some are not. And it says, let F be the set of books that are fiction. So F is going to be our fiction. And then the E circle represents those that are ebooks. All right. On the Venn diagram, shade the regions representing the books that are available as ebooks, not works of fiction, and so on. You'd be surprised that some of these will get you. So if you want, you can pause the video and try it yourself. I would suggest picking up a pen or pencil and just shading what you think is correct. Maybe go with a pencil if you're not totally certain. Right? But if you want to, pause now. Otherwise, I'm going to keep moving. So Available as an ebook means anything inside the ebook circle. So anything within there, all right? That would be the available as ebooks, all right? And now what's this greater set? The greater set is like everything like available in the store, okay? So that's what like the big box would represent here. For part B, not works of fiction. So everything inside the F circle counts as a work of fiction. So it'd be all this stuff outside of it, anything that falls outside, whether it's an ebook or something that would fall outside of here. All right, part C, works of fiction available as ebooks. Oh, and there's the keyword, and available as ebooks. So this is only the overlap. This would be that little part right there. So that's just that. Okay. Works of fiction or available as ebooks. That means this is the union. This is where it's the family reunion. You include everybody. So anybody that's fiction, anybody that's an ebook, and of course, if you're in the overlap, bonus. All right. Last part, neither a work of fiction nor available as ebooks. So you can't fall in this circle and you can't fall in this circle. So in that case, you would be everything outside of here. So maybe these are all your nonfiction stories that don't have ebooks available. Right? Over here, works of fiction that are not available as ebooks. So they can't fall in the ebook circle. So it has to be outside of there, but it's got to be inside of here. So what that means is it's going to be the works of fiction that aren't in the overlap. So just this part over here. All right, there you go. Usually people get stumped on like one or two of them here, but hopefully you got all 6 of them. All right, this next example that we're going to look at, I don't think is on the notes that are posted online. So if you're watching the video, you get a little bonus example here. It says, consider the set of all integers 1 to 10 to be our sample space, S. Let A be the set of all integers that are odd. So S is going to be all the odd numbers. All right. And let B be the set of integers that are multiples of 5. All right. Fill in the circles in the Venn diagram with the elements from S. So now the idea is you don't want to list them more than once. So you have to figure out like, where should 1 go? Where should 2 go? Where should 3 go? So if you need to, make a little list off to the side. So the odds, 1, 3, 5, 7, 9. Multiples of 10 would just be 5 and 10 in this case. All right. And so, I said S. Let A, you never saw that. Let A be the odd ones. B are the multiples here. So if the only value that appears twice is 5. So that has an overlap in the center. So the 5 would go here, right? The 10 that goes in set B definitely is not in set A. So 10 would just be all by itself over here. The rest of these guys, 1, 3, 7, and 9 would be over in set A. And then everything else that we haven't mentioned yet. So we already did 1, we did 3, we did 5, we did 7, we did 9, and 10. So 2, 4, 6, and 8 would be floating around on the outside. So 2, 4, 6, and 8. There you go. Right? So they all belong somewhere. It's just whether or not they belong within those specific circles you have to think about. All right. So that was the bonus example there. Let's bring it on over to the next page here. And now we start playing with some numbers. All right. So when it says when a fish is selected at random from a tank, the probability it has a green tail is 0.64. The probability it has red fins is 0.25. The probability it has both a green tail and red fins is 0.19. Mm-hmm. So you can do a couple things with this. There's multiple ways to show this. One way is with a Venn diagram. Another way is with what's called a two-way table. So we're going to show both of those. So the first one, a Venn diagram, means draw the big universal set here, right? So this is essentially like all the fish in the tank. You don't really have to label that. I just want to make sure you understand that, all right? And then we've got circles for green tail and red fins. So I'm going to use G for the green tail. And the probability of G is 0.64, and I'm going to use R for the red fins. And I'm going to do the probability of R equals 0.25. So then when we say both, that is the probability of our intersection G is 0.19, which what that means, this is the part that goes in the middle. Right? So 0.19 would go dead center. Now here's the part that sometimes people get a little thrown by. You can't just take this 0.64 now and put it over here. The idea is that that whole circle has to represent 0.64. And if 0.19 is already being represented in the center, then you have to do a quick calculation here. So 0.64, ooh, there's a little tangent graph for you. 0.64 minus the 0.19 that's already being accounted for would leave us with 0.45. So when you subtract 0.19, 0.45 is what's going to go in just the green part over on the left. And then you can play the same game for the red. It's supposed to be a total, I'll even use my red pen here, a total here of 0.25. So you got to subtract out the 0.19, which would leave us with 0.06. So 0.06 would go over here. All right, well, here's the question. What goes on the outside? So in the last example, we were just told how many elements there were. In this case, when they're probabilities, what we have to think of is that the total probability, if you consider all the cases that could possibly happen, they should all add up to 1. That's the key here. So right now, if we do 0.45 plus 0.19 plus 0.06, let's see what that brings us up to. 0.45 plus 0.19 plus 0.06. That's going to be 0.7, which means if you do 1 minus that, we're left with 0.3 kind of hanging out on the outside. Now, they didn't specify what the last 0.3 was. So it might be just whatever, different colored fish. Don't care. Don't overthink it. All right. But put that value out here in the corner. Now that you have everything, now you can answer the questions. So when it says use the Venn diagram, find the probability that the fish has red fins but does not have a green tail. So think about the practice you just did on the last page. Has red fins means it's in this circle, but not a green tail means it can't be in that overlapping part. So that is the red only. That's that 0.06 right there. A green tail, but not red fins. Now you're just playing it in reverse. So green tail, but not in the overlap. So that's the 0.45. Right? Neither a green tail nor red fins means you can't be anywhere in these circles right here. So that's that 0.3 that we found on the outside. So that was that work that we did over here. Oops, I'm off the screen there. All right. Now, if we look at that same question, showing this with a little two-way table, this is kind of a cool way to do it. Some of you will have a preference where you like Venn diagrams better. Some will like two-way tables better. There's no one right or wrong answer, but I will say that two-way tables are super friendly here. So what I want you to look at is on the left side, we've got red fins and not red fins, green tail and not green tail. So we're going to fill in the probabilities based on what we know from above. All right. So if I go back to the question and look at it, we are told that the probability that they have a green tail is 0.64. So that's all the fish with a green tail. That would actually come down here and be our 0.64 right there, all right? Because that's the total, all right? Then you're told the probability red fins. So the total for having red fins, that's 0.25, all right? So that's the information that was given to us right out of the get-go. And then we're also told they have both a green tail and red fins as 0.19. So red fins and a green tail, 0.19. So these three pieces of information were given to us in the chart. Now I'm going to show you how we would get all the other pieces based on that. All right. So if I have 0.19 here and a total of 0.25, you have to figure out, okay, well, what would be the missing piece right here? So that's just simply 0.25 minus 0.19. And that, oops, typed that in wrong, minus 0.19. There's 0.06. All right. Right here, 0.19 plus what would give you 0.64? Well, subtract that 0.19 from 0.64. There's 0.45. All right. And now you can fill in the rest. The total altogether, we said, should be 1 over here. So 0.64 plus what would give me 1? Well, again, just do some subtraction. So 1 minus 0.64, that's going to leave me with 0.36. I can play the same game over here. 0.75, you guys don't even need a calculator for that. That would be 0.25, which means that's 0.75. All right. And now you can fill in this way or this way. So think 0.06 to get to 0.36. You're missing a 0.3 right there. And now does it check if I go this way? 0.45 plus 0.30, that's 0.75. Absolutely. Right? And that was the not green tail or not red fins. That's the 0.30 that's sitting in the corner of the chart there. Right? So the idea is that you add and get the total here. You add and get the totals here. And then these together should add up to give you 1. These together should add up to give you 1. Yay. And it all works out. Okay. We have one last page to look at. Let's flip it on over here. This page is definitely a little bit different, the way that it's laid out than the notes on the website. Again, it's all the same information. So if you're looking on the website to help, it just might be like reordered a little bit. Otherwise, it says, consider the available vehicles at a certain dealership. Suppose that of the 200 vehicles at the dealership, 144 are sedans, 120 are sedans, but do not have manual transmission, sorry. And then 38 are sedans. That doesn't seem to make sense. 120 are sedans, but do not have manual transmission, and 38 are sedans and do not have manual transmission. Not going to fit. Not understanding that one. All right. You know what I'm going to do? I'm going to double check and make sure I don't have a weird typo going on here, and then I will repost a video for this last page.